Welcome to this session. Thank you for joining. In case you don't know, this is about quality assurance for machine learning. And I'll first introduce myself. So my name is Serg Masis. Serg is my English nickname, but you can call me Sergio if you speak Spanish. I'm a data scientist at Syngenta, where I work on food security problems for the computational agronomy department. And I wrote a comprehensive hands-on overview of interpretable machine learning. And I'm currently writing one called Do It Yourself AI for Pearson's publication. This is actually my second career. For over 10 years, I was a full stack web and mobile app developer, a webmaster, and even the founder of a startup. In these roles is how I got into analytics, since the internet is often the source for big data. Without further ado, let's dig in. So this session is divided into 4 sections. First, I'll explain what is QA. Everybody thinks they know what it is, but it's far more than you probably think it is. And then what is needed to implement quality assurance in AI, and what does explainable AI have to do with quality assurance? And then finally, like a quick recap. So for those who don't know or want a refresher, QA or quality assurance is the discipline of making your product suck less for your end users. And let's see some examples of how products can suck. Some of you may be too young to remember, but Microsoft Windows was notable for having setting crashes that resulted in a blue screen, which was aptly named the blue screen of death, because it meant you probably lost all your work and had to restart the computer. Obviously, if you hadn't backed up your work, it would be lost. And sometimes even your entire hard drive would be unusable after one of these events. Well, there's also the question of maintainability. I don't know, for those of you in the US, you probably know this. It's notably really hard to get a McFlurry or any kind of soft serve product at McDonald's. This is because the My Screen machine requires maintenance all the time, pretty much by design. This really creates a poor user experience. But of course, like the sales of soft serves are probably not enough to warrant like changes in this regard. But if all they sold was soft serve, they would be out of business. So performance, we usually associate Formula One with speed, but back in 2003, there was a McLaren that was a huge disappointment. It was called the MP418. It was never released in huge numbers, obviously. And then design. You don't have to go look far to find poorly designed products. I could have, even Apple has had bad designs, but of course you can look at this and know exactly why something like this wouldn't work. There are other aspects that matter to end users, of course. QA can practice with anything we care about. It doesn't have to be like only these 4 things. It could be absolutely anything, that matters to end users. So how did it all start? The timeline of quality assurance spans about 9 decades. And it all started with statistical quality control, which measured how products at the end of an assembly line statistically differed from each other. However, the birth of quality assurance happens during World War II, when more than the end result of the assembly line are tested. Because sometimes it's not the only thing that matters. You have to, as we looked at some of the examples, it's not what happens in the assembly line. Maybe the urinals were well designed or the mouse or whatever, but once the users interact with it, something wrong happens. So throughout the decades, quality assurance is expanded to include other things like raw materials, packaging, processing, user experience, etc. In the 1980s, it's computerized with quality management systems. And in the 1990s, um, management itself is incorporated into quality assurance with the concept of total quality management and ISO 9001 standards. Unfortunately, most AI is here. And I'll explain why in the next 15 minutes. So there are three related concepts, but they sound like they're the same, but they're not. Okay, so testing, quality control, and quality assurance. First of all, testing. Testing focuses, when related to software, to code and design. And basically finding defects in functionality and design upon completion. It involves test engineers and developers. Then we have quality control, which focuses on verifying a whole product throughout its development and release. It involves the entire development team. And then there's quality assurance, which focuses on preventing defects throughout the entire process. It's proactive and involves all the team and their stakeholders. Quality assurance includes quality control, and quality controls includes testing, in case that's not obvious. They're like overlapping in that sense. But also quality assurance is not just about the tech. ISO 9001 principles for quality assurance is much more than technology, because to work, it has to enact change in several areas. And in the field of change management, change is usually broken up into technology, processes, and people. And as you can see, most of the principles have to do with people. So like here, mostly technology related. This is the orange is mostly process related, and see, mostly people related. So everything involving leadership and leadership functionality, customer interaction, and so forth, and relationship management, and so forth. All that involves people. So people are a large part of the equation, larger than we think. So a perfectly valid question would also be, if software development has had quality assurance as best practices since the 1980s, what's stopping AI development from adopting the same methodology? There's a reason AI is much more complex than quality assurance and traditional software development. Traditional software has a program that was written by humans, of course. On the other hand, machine learning trains a model, which is usually a very complicated series of mathematical operations, to turn data on the way into predictions on the way out. So the model is essentially a program, but it's usually a black box, and it's not understood by humans. Likewise, non-technical stakeholders don't understand the process. They don't understand the training process, at least holistically. And since there are many ways to develop the process and the end result are often subject to a lot of debate, among many actors involved in the process. So even if they fully understand the process, they don't agree on how we came to use that process. As you can see, there are issues with the technology, processes, and people. So what steps can we take to incorporate quality assurance in AI? Well, let's start with the people. There's at least 4 groups of actors involved in AI development in most organizations. And these 4 groups have different objectives, from KPIs to operational efficiency, and there's friction between them, which former director of data engineering of Slack, Josh Wills, called the infinite loop of sadness. He calls for improving collaboration and communication between these groups to foster empathy and align objectives. To do this, all you need is better communication at all stages of the process. So that may seem very taxing, but it's doable as long as people are telling you things that are relevant to each other in the language they understand and according to the objectives they mostly care about. So the second thing, and I guess this goes without saying, but the raw material of any AI project is data. And any successful AI project relies on high quality, reliable data. But as they say, garbage in, garbage out. Another important component is to make sure that your AI system is scalable. To increase the amounts of data and devices, which is usually called technical scalability, and also to user demand, which is operational scalability. As for reproducible, it's important that any process or analysis in the system returns the same output when it's given the same data. So this is the only thing we concern about at this stage, that it's reproducible. And then the next thing is a rigorous methodology. Is that you follow a logical series of steps to take a problem and solve it with machine learning model. And then an iterative approach is that you learn from what went wrong or right in each modeling iteration and decide on improvements, which you plan to apply in the next iteration. A data-driven approach calls for focusing on improving the data rather than the model. So if you're thinking the last 5 points are so obvious and easy peasy and your company has surely overcome them, it's the next critical 3 points where most companies fail with quality assurance. So once you have a rigorous methodology to train and deploy a model from start to finish, an approach to keep iterating said model, the next step is to automate the process with a continuous evaluation and monitoring while following the best software practices. And this is easier said than done. We call this MLOps. And of course, this is an MLOps conference, so I'm just stating the obvious here. But something that's usually missed, even in the best MLOps practitioners, is enforcing quality assurance throughout the entire process in a very holistic manner. And there's more to it than meets the eye here. So we'll get into that in a bit. The quality assurance wouldn't be as powerful if someone is trying to break the system. We must actively look for model weaknesses than to simply confirm strengths. This is why AI development should approach quality assurance adversarially. Perhaps this means having QA testing performed by a separate specialized team, like it's often done in software development. Usually, in a lot of software companies, the QA testers are a separate team. And well, I wouldn't say they hate each other, but there's some animosity, towards the people writing the tickets and the people performing the fixes based on those tickets. But often testing won't pick up on everything because the AI model is a black box. How can we expect it to improve something we don't understand? Every AI project should prioritize interpreting models, allowing practitioners and stakeholders to understand the underlying patterns and relationships driving the results. So that's why we have model interpretability and explainability. So I can't stress enough how important explainable AI is for quality assurance for AI. Allow me to explain why. Imagine the machine learning model is a plane. Which plane would you rather fly in? The one to the left or the one to the right? The one to the left is like using metrics alone to improve your model. The one to the right is like using all the tools explainable AI has to offer. It gives you the control to pilot machine learning pipeline under the worst data conditions. So while the plane to the left, you can fly on a clear blue skies kind of day, with no thunderstorm in sight, you would only trust the one to the right under the worst conditions. And it's basically the same thing. When it's like, take the example of a large language model. Like if you ask it, data that was pretty much, a billion times in its training data, offered so many different ways, of course, it's going to give you a very consistent answer that you expect, right? But if you give it something that is completely out of scope, that is very difficult, and you never tested it, of course, it's going to have a harder time. And that's what I mean by worst conditions. um, so quality assurance in AI is performed throughout the process, from data acquisition to modeling to monitoring. And there's pretty much 4 quality assurance tasks that are done throughout. I mean, the first 2 you're probably quite familiar with: data cleaning, data validation, and then there's rinse and repeat. But there's model evaluation, and often the problem with model evaluation is that it's not that it isn't done; it doesn't done as rigorously. It only encompasses performance. It doesn't encompass consistency, robustness, adversarial robustness. It doesn't encompass every kind of metric that could be valuable. It might only focus on a single metric. And then usually it lacks model interpretation, and we could go pretty far deep into what model interpretation could do. From finding counterfactuals that are inconsistent to explaining specific model outputs. So I work in agriculture. I just wanted to provide a few examples from agriculture to give you an idea of what explainable AI can do in that. These are like model evaluation and model interpretation examples related to the field. So if you work as a machine learning practitioner, you can apply similar methods to your work, I'm sure. One thing, and that's what I mean by looking at model evaluation more holistically. You look at it as an error analysis, and you're trying to find weaknesses of a model. You're going to find weaknesses, and it's not good enough to look at the aggregate metrics of a model and say, okay, it's you have to find the weak spots and see how you can improve them. That's how you iterate and make. That's like the data-driven approach to actually improve a model. And it's often a lot of work, but it's well worth it. So here, basically what we're seeing is that you can draw up a graph like this and look where the residuals are kind of lying. What's the distribution of the error? And we can break down the error by different dimensions. Many gains can be achieved by understanding them and then mitigating them. Quality assurance starts here, I think. And this is not necessarily like throughout the pipeline. When you're running the MLOps pipeline, it might not be like every single time you release a new model, because you're releasing it every day. It depends what your timeline is. But it might be on every iteration where you're going to improve the model, improve the data quality checks that you do within, and even the data preparation and cleaning and all that. And then, well, I failed to say this is for a weed treatment model. I guess the specifics aren't really that important. What's important here is that even in something that you don't think about a lot, like agriculture, we try to look into these sort of things and see where we can apply the model effectively and where we cannot. Then there's model interpretation. You can look at what is called global model interpretation, and this is for a crop growth model. Global interpretation methods are those that seek to understand general aspects about the predictions or operations of the model. And in feature importance, we seek to rank features by which ones the model leverage the most to make predictions. This matters because we can tell the model's learning from what it should be learning. And if you have an MLOps pipeline and you're not checking that your features importance hasn't drifted, then you're doing all wrong, because it might not be that obvious to you that there's been a change, because the model could be right for the wrong reasons, and that could be a very dangerous thing depending on your work with. It makes sense, like whatever this says, it has to be intuitive. So if you look at this, you say, well, of course, predicting crop growth has mostly to do with the amount of daylight, so this completely makes sense, right? So you go down this list, and you, with the domain knowledge expert, and you look at, you properly assess each one to make sure that it's actually makes sense. The next one, and the last one we're going to look at, is predicting plant diseases with images. What local interpretation methods seek to do is explain the reason for a single prediction. And here we can see what part of the leaf each method attributes to the model's predictions using an attribution map. And there's many kinds of many ways of doing methods for attribution maps. And you could go on and figure out which one does the best job at that. But what's important here is that this is something we can use to assess. It's part of the tool set we can use to assess the quality of a model. And we can create tests around these things. We could have a test set that we use every single time we train this sort of model, so we can consistently compare and see if the model has improved, if there's been some kind of drift in the kind of data, maybe there's a new kind of leaf or new kind of a disease where we weren't previously assessing. And so we have to understand how these things can shift, especially over time. So now, lastly, we're going to go into the quick recap before I end the session. So first, testing, quality controls, and quality assurance are related but not the same, because we respectively focus on detection, verification, and prevention. Being proactive is, of course, better than not. So that is something you find towards the end of this, this progression. And the problem with AI development, as currently practiced, it's that it hasn't caught up to software development. And to produce the level of reliability people expect from an AI application, we ought to, because it's usually like either a drop-in replacement for software or an improvement upon software. So it has to have that level of reliability whenever possible. So to fix this, we need more collaboration and communication, which within all parties involved in AI development, then focus on data quality and reliability and scalability and reproducibility, and then connect it to a rigorous methodology and an iterative approach with automation to create a solid MLOps system. Then even if your software company has all of the above, which I'm sure many of you do, without an adversarial approach to quality assurance and model explainability and interpretability performed on several stages and on levels, you haven't quite got everything yet. And I feel like this is still like something that's still evolving. There isn't like an ISO 9001 quite yet to encompass all of this, but there will be at some point. There has to be, because otherwise, like we're not going to make this work consistently for everyone and for every use case. So that's it. Thank you for your time. I'm open for questions. You can also reach me at LinkedIn and Twitter too. Okay, let me go over the questions. Will I discuss quality assurance with respect to large language models? Something I've struggled with is prompt regression under retrieval augmented generation. Ah, interesting. I've never seen this use case. It is kind of tough to go back to where things, to the genesis of things, according to a large language model. Like there's different approaches to that. There's recent papers, I don't have them on the top of mind, but that have to do with kind of not so much the prompt engineering, but even asking the LLM, why do you think of it, going through its thought process, if you can call it such. It won't tell you the source, but at least can tell you how it arrived to a conclusion. And then the other thing is there's a framework, there's several that have come up recently involving causal notions and things like that to kind of make it easier to understand what the LLM is doing. And in the case of retrieval augmented generation, it should be a lot easier because you're giving it the answers. You're pretty much giving it the answers and telling it, kind of relay this back to the end user, or process it in a certain way and relay it back. Well, that's usually like the thought process, unless you're giving it like entire documents and saying summarize it or something like that. So it depends on your use case. I don't know if that's what you meant by prompt progression, but hopefully it is. And then, do you think enabling explainability interpretation requires we to do AI or ML development differently? No, it's just another step in the process. I think it's often not the issue. Like, people would like to do it, but there's just a lot of time spent on the initial parts of the process that by the time you get to deployment, you kind of, it's an afterthought. It's no longer, okay, I'm going to devote. But if it was a hell lot easier, and it's often the case, especially as you've developed the same model over and over again, improved and iterated, there's extra time to work with this usually. It's not like when you're working on model 0, you're not thinking about these things because it's like, all right, it still doesn't have users. Why does it matter yet? It's still kind of a proof of concept. But the point, it does always matter because it's you have to develop that muscle memory of adding it into the process. Okay, I don't want to go over time, but what's your take on handling model QA when production data can't be used in quality assurance? Typical. Oh, yeah, that's tough. It's tough when you have to have privacy preserving machine learning. I don't know. I've never actually done QA on that kind of environment. So I can't really properly answer that question for you. Thank you for the ISO standards. Yeah, I that's good that it's coming through. And thank you all guys for joining. I don't want to go over time, but I appreciate you guys joining.